Okay, welcome to topic 3. We're going to study some special quadrilaterals, actually special parallelograms. And remember, a quadrilateral has 4 sides, and this is a convex. All vertices are pointing out, and this one is concave because one of them is pointing in. And a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So let's talk about what all that means and what all that implies when I have a parallelogram. So I have shown that side A, B, and side CD are parallel, and BC and AD are parallel, and that they're also congruent to each other. And opposite angles A and C are congruent, and B and D are congruent, and consecutive angles. So angle A and B add up to 180, A and D add up to 180, and so on and so forth. And the only thing I'm not showing here right now is that the diagonals, so diagonal AC and diagonal BD bisect each other. They're not congruent. The diagonals aren't congruent, but where they meet in the middle, they do bisect each other. So 3 very special parallelograms. So these have opposite sides parallel, and all these other features we just talked about are all there, but these are special. First is a rhombus. A rhombus has where all 4 sides are congruent. So all 4 of these sides are congruent. It still has opposite angles are congruent, and diagonals bisect each other, and so on and so forth, but this is what we have special. A rectangle has 4 right angles, so each one of these angles is a right angle. Notice opposite sides are congruent, but not all 4 of them are the same. And finally, a combination of the two is a square. A square has 4 congruent sides, 1, 2, 3, 4, all 4 sides are the same length, and all 4 angles are 90 degrees like a rectangle. So a square is a rectangle, and a square is also a rhombus. So in the Venn diagram of quadrilaterals, any 4-sided figure, special part of it is parallelograms, two pairs of parallel sides. Inside of that, we have rectangles with all right angles, rhombuses with all 4 congruent sides, and then in the middle, that shares both ideas, is a square that has all right angles and 4 congruent sides, and there's more space. There's more things in quadrilaterals. We'll talk about that at a later date. So we're going to play the game, is a statement always, sometimes, or never true? Is a rhombus a rectangle? Well, the answer to that is sometimes. And the answer is sometimes if that rhombus happens to be a square. Is a square a rectangle? That is always true. By definition, it has 4 right angles, therefore every square is a rectangle. Is a rectangle a square? Again, that is sometimes true. Only when it's a square. Not every rectangle is a square, but if a rectangle is a square, it is a square. Is a square a rhombus? That again is always true. Every square is a rhombus by definition. It has 4 congruent sides. And is a rhombus a square? Sometimes. So a rectangle is a square if the rectangle has all 4 congruent sides the same, and a rhombus is a square if the rhombus has 4 right angles. Okay, so it says draw the diagonals for each of these figures. So for a rhombus, rectangle, and square, I drew the diagonals, both diagonals in each. Because these are parallelograms, those diagonals do bisect each other. But other properties are going on. Let's see what's going on. So let's just do it from our eye test and see what's going on. So, are these diagonals congruent? Do you think that AC and BD are congruent? I think AC is a lot longer, so that's definitely a no for the rhombus. But these rectangles, I think in these rectangles that these very much look the same, and if you think about this by Pythagorean theorem, the blue side squared and the red side squared is going to equal the green and vice versa, so that is a yes, and I think the same thing for a square is a yes. Okay? Are the diagonals perpendicular? Do you think in the pink that those diagonals are perpendicular? I think they do look perpendicular. So that is a yes. Do these look perpendicular? I don't think these look so perpendicular. I think these look does not look like a 90-degree angle. But I think these, to the best of my ability, drawing these diagonals, that this is also yes. Do the diagonals bisect each other? And that is always true for any parallelogram. They always, always, always bisect each other. The only thing going on in this picture is that if it's a rhombus, which also means for a square, that the diagonals bisect opposite angles. So from this picture, that means angle 1 is congruent to angle 2. And over here for the square would be the same thing, that this angle 1 is congruent to angle 2. And the same thing at angle B, if I call them 3 and 4, so on and so forth, that these diagonals are special. It doesn't happen with squares. In squares, those diagonals are not bisecting those angles, but in a rhombus and a square, it does happen. So let's play match the properties. So my 4 figures I have are parallelogram, rectangle, rhombus, and a square. And I have these 6 ideas, and it could be more than one answer. So the diagonals are congruent. Well, in a rectangle, in a square, they are congruent. Both pairs of opposite sides are congruent, and that's for all 4 items. That always happens. All angles are congruent. That's only for a rectangle and a square. Both pairs of opposite sides are parallel. Well, again, that's for every parallelogram, which means all 4 of these. All sides are congruent. That's only for a rhombus and a square. And the diagonals bisect each other. And that is for, well, I guess it's for all of them. The diagonals always bisect each other. So A, B, C, and D. Now again, we're going to do playing the game A, B, C, D for the parallelogram, rectangle, rhombus, and square, given only this condition. So if diagonal MT is perpendicular to diagonal AH, that means that would only be a rhombus, because other things would happen if it was something else. So MT equals AH, that means the diagonals are equal to each other, and that would be rectangle B, because something else will happen. So the next one says, not only the diagonals perpendicular, they're also equal to each other. That's a square. A square has both conditions. And then finally it says, MO and OT are congruent, and OA and OH are congruent. That means the diagonals are bisecting each other. And even though that happens in all the cases, if that's the only thing that's going on, that's just a parallelogram. Okay, let's solve some of these problems based on what is given to me. And if ABCD is a rhombus, I know that these diagonals are perpendicular to each other. So angled at 3x is equal to 90, or x is equal to 30. Over here, if this is a rectangle, these two sides are congruent. So 5x minus 13 equals 2x plus 17. Bring the 2x over, add the 13. I get x equals 10. And finally, this is a square. That means these two consecutive sides are equal to each other. So 2x minus 14 equals x plus 15. Bring over the x, I get 1x. Add over the 14, I get 29. X equals 29. Okay, BDEG is a rectangle, which I highlighted in pink, and ABCD is a rhombus, which I highlighted in green. Well, since this is a rhombus, I know these diagonals inside the green rhombus are perpendicular to each other. And I know that this is a rectangle, so this angle here in the corner is a right angle. That means this angle 63 degrees means this angle here is 27, which means I have this green, pink, side C triangle, which means the 63 degrees left over for that. So, should be able to figure out a little bit more here. That 27 by alternating triangles, this is 27 degrees, this is 63, and because these two sides are the same, this is also 63 degrees. That's 126. That means this angle here is 54 degrees, and so on and so forth. And I believe the way it works out, if this is 63, and this angle here is also 63, this is 27, here's 90. So angle GDB is 27 degrees. Angle DAB, well, this is 63. The other side here is also 63, so that's 126 degrees. GCE, well, 63, 63, these are also 126 degrees. AHB, it's the bisects from 90-degree angle. ABC, well, these two 27s are the same thing here. It's 54 degrees. BCG, which I did earlier, is also 54 degrees. DEG is a 90-degree angle. And DGB is a 63-degree angle. So this is a rhombus, so for all four sides are the same. And I'm doing BAE, this angle is 32 degrees. That means ECD will be alternate angles, it's also 32 degrees. Angle EDC right here at the bottom is 43 degrees, so CBA, well, this is 43 degrees. This one here is also 43 degrees. That means this angle here is 86, and across from it has to be the same, 86 degrees. EAB is 57. This angle here is 57. So we're trying to do EDC, ADC, let's see. So EAB is 57. That means this side here is also 57. So together this bigger angle is 114. And together angle A and angle D have to add up to 180, so that leaves 66 left over for that. And if angle BEC have to equal 15, well, that's a right angle, so I have to do 3x minus 15 equals 90. 3x equals 105. I get x equals 35. We'll choose the color. So angle ADE and CBE, they would be alternate interior angles that have to equal each other. So I'm going to set these equal to each other. And I get x equals 16, and angle BAD, BAD, and ABC. Well, those are two consecutive angles. They would have to equal 180, so I have to do 4x plus 14 plus 2x plus 10 equal 180 degrees. I have to solve for x. And when I do the algebra, I get x equals 26.